Welcome to the video lecture on sensors and transducer. So, as we know that sensor is nothing but it's a primary sensing element. Okay, so that we are going to sense the object. Okay. So whether the object is electrical quantity or non-electrical quantity, whatever it may be, but sensor will be sensing the object. That is called as the primary sensing element. Okay. So then definition of transducer. So transducer is nothing but, so it is going to convert the non-electrical parameters into some useful electrical parameters or some useful electrical quantity. So ultimately transducer is nothing but it is going to convert one form of energy into the another form of energy. But for our discussion, I call it as it is going to convert non-electrical quantities into some useful electrical quantity. Okay. So today we will discuss the measurement of non-electrical quantities. As your with your prescribed syllabus, it is the 5th module. Okay. Module 4 and some part of non-electrical quantities are in module number 4 and some quantities are in module number 5. Okay. So I will start with the measurement of non-electrical quantities. Like, so again there are many non-electrical quantities. So those are pressure, okay, force, temperature, liquid. Okay. So these are some of the non-electrical quantities which we are going to measure here. Okay. So in the module number 4 and module number 5. So let us discuss with the measurement of pressure. So already the term measurement, the term pressure we know very well. Okay. So pressure is defined as a force per unit area is nothing but pressure is defined as force per unit area. Okay. So then the pressure may be exerted by the gases or vapors or liquids. It may be any form. It may be gases. It may be in the form of gas. It may be in the form of liquid. It may be in the form of pressure. For example, let us say. So this is the one choppice. Okay. So this choppice presently it is in the standstill condition. I want to move this object because it is a non-electrical quantity. Okay. I need to move this quantity from this place to this place. What I will do? So I will apply some force on the choppice. Okay. So it starts moving. It means it needs some pressure. Okay. This is a one type of pressure we are applying on the object. So I will demonstrate one more example. So let us look at this. See. So now I apply some air pressure here. Then again it moves from one place to the another place, right? So that is the how we are going to apply the force on the objective. Okay. So then the unit of pressure is Newton per meter square. Okay, or in short form we write it as Newton per meter square or kilopascal, or Pascal. In short form, we write as PA. Okay. So this is the unit of pressure. So normally, if we are going to study the pressure, for example, the atmospheric pressure. Okay. So as we are living on the atmosphere, first we will study about the atmospheric. What is the definition of atmospheric pressure and all the things. Okay. So atmospheric pressure usually will study at the sea level. Okay. So we will draw one graph. Okay. So this y-axis we call it as the pressure, and this x-axis we call it as the zero absolute pressure. So here we have the atmospheric pressure. Here we have the line. So this region we call as the negative gauge or vacuum gauge, vacuum pressure. So this region we call as the positive gauge, pressure, positive gauge pressure. So this region we call it as the absolute pressure. So let us study one by one. So first we will study the gauge pressure. Gauge pressure. So gauge pressure is nothing but it is a pressure. Okay. So it is going to measure between the atmospheric pressure. Okay. So this region we will call it as the gauge pressure. Surrounding the atmospheric pressure we will call it as the gauge pressure. Then the negative gauge pressure is nothing but below the atmospheric pressure and above the absolute pressure, we call it as a negative gauge pressure. Similarly, the first two gauge pressure is nothing but it is the above the atmospheric pressure, we call it as the first two gauge pressure. Okay. Then the absolute pressure. Again, absolute pressure is nothing but it is a pressure. It is above the absolute zero pressure. It is called as the absolute pressure. Usually, the atmospheric pressure will call it as the standard atmospheric pressure. The atmospheric normal, atmospheric on the surface, we call it as the standard atmospheric pressure at the sea level. So its value is the standard atmospheric pressure at the sea level value is 101.3 kilonewton per meter square. This is the standard atmospheric pressure at sea level. So then mathematically how we are going to write the atmospheric pressure. Okay, so let us write the mathematical representation of the atmospheric pressure. Mathematically representation, call it as mathematical representation of absolute standard atmospheric pressure. So we are going to write it as absolute pressure is equal to, okay, already we know the atmospheric pressure is nothing but the standard atmospheric pressure is having the 101.30 kilonewton per meter square is the standard pressure. But when you are going to represent it mathematically, then it comes as a absolute pressure is equal to the atmospheric pressure plus atmospheric pressure plus the combination of positive pressure gauge or plus negative pressure gauge, or simply the addition of these two, I call it as the vacuum pressure. Okay, vacuum gauge pressure. So vacuum gauge pressure. Gauge pressure, or this absolute pressure we are going to write in a short form, that is PABS. The abbreviations we use for the absolute pressure is PABS is equal to atmospheric pressure PATM plus P gauge. Okay, so mathematically in short form, this we are going to write it as PABS plus PATM plus P gauge is nothing but the absolute pressure. So similarly, the vacuum pressure we are going to write it as vacuum pressure is equal to absolute pressure, okay, because we are measuring this vacuum pressure. Okay, so if we subtract the absolute pressure among the atmospheric pressure, we will get the vacuum pressure. Okay, vacuum pressure is equal to absolute pressure minus atmospheric pressure. So this is the vacuum pressure. Then apart from these two, absolute pressure and the vacuum pressure, we have another pressure, that is the total pressure. Total pressure is nothing but the addition of atmospheric pressure, absolute pressure and the vacuum pressure. We use the total pressure of the sea level. Okay. So then there are many categories or classification of pressure depending upon the pressure we are going to divide it, like low pressure, medium pressure and high pressure. So then there are many components to measure the pressure. So in that, manometer is a one type of instruments where we are going to use to measure the pressure. Okay, so